Hello, and welcome to Math with Usna. In this lesson, we're going to talk about using triangles. We will introduce some theorems about triangles, and then we'll work through some examples. Our first theorem is called the Triangle Sum Theorem. It's one that you're already familiar with, but we're going to formalize it. It just says that the sum of the measures of the interior angles of a triangle have to be 180 degrees. Exterior Angle Theorem. The measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent interior angles. We've discussed in a previous video what exterior angles are, so if you need a refresher on that, feel free to check that out. But let's draw a picture of what this looks like. Draw a triangle, and I have got an exterior angle. This theorem says that this angle right here, this exterior angle, is equal to the sum of these two angles. We can also call them remote interior angles instead of non-adjacent. They're both okay. So the exterior angle is equal to the sum of the two remote interior angles. Corollary to the Triangle Sum Theorem. Now, a corollary is a statement that's made based off a theorem. So we could have a theorem and then say, well, because this theorem is true, this is also true. That's called a corollary. This one says that the acute angles of a right triangle are complementary. Let me draw out a right triangle. Why is this true? Okay, I know that this angle right here is 90 degrees. I also know that all triangles have to add up to 180. So what's left for those two remaining angles? 90 degrees. These two angles here have to add up to 90 degrees. That's what the corollary is saying. And the last one, Third Angles Theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. I'm going to erase this so I can draw what this looks like. I'm going to draw two triangles. And it says two angles of one triangle are congruent to two angles of another triangle. So let's say this angle is congruent to this angle, and this angle is congruent to this angle. What this theorem says is if you have this case where two angles of two triangles are congruent, then it has to be true that these third angles are also congruent. Because we know that they have to add up to 180, two of the angle pairs are already congruent. What's left also has to be congruent. So Third Angles Theorem, if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. Let's solve for the missing angles in the triangle. We've got triangle ABC, and I've got angle measures, and I want to find out the missing angles. I know that the Triangle Sum Theorem says that the angle measures have to add up to 180, which means the measure of angle A plus the measure of angle B plus the measure of angle C equals 180 degrees. I'm going to go ahead and substitute what I know, 6x plus 9 plus 2x plus 16. Well, that's actually for angle C, so I'm going to keep it in the right order. So 111 plus 2x plus 16 equals 180. Let's combine our like terms. We've got 6x and 2x, and then we've got 9, 11, and 16. 6x plus 2x is 8x. 9 plus 111 plus 16 is 136 equals 180. And we'll subtract 136 from both sides. We get 8x equals 44. Divide by 8 on both sides. We get 5.5 or 5.5, however you want to write it. I'm not done yet. We have to make sure that we're actually answering the question here. The question doesn't say solve for x. The question says solve for the missing angle measures. What we want to do is take that x value that we just found and substitute it back to find our measures for A and C. Measure of angle A has to equal 6 times 5.5 plus 9. That's going to give me 42 degrees. The measure of angle C is 2 times 5.5 plus 16. And that's going to give me 27 degrees. So my final answers are 42 degrees and 27 degrees. Let's try another one. We want to solve for the measure of BCD if the measure of BCD is 3y minus 16. I'm going to put that in first. 3y minus 16 degrees. The measure of angle A is 2y degrees. And the measure of angle B is 88 minus 3y degrees. 88 minus 3y degrees. While BCD is an exterior angle, and angle A and angle B are the remote interior angles, or the non-adjacent interior angles. My theorem says that the exterior angle has to be equal to the sum of the remote interior angles. The measure of angle BCD has to equal the measure of angle A plus the measure of angle B. I'm going to substitute everything that I know. So I know BCD is 3y minus 16. The measure of angle A is 2y. And the measure of angle B is 88 minus 3y. We're going to combine like terms. 2y minus 3y is negative y. I will add y to both sides. 4y minus 16 equals 88. Add 16 to both sides. 4y equals 104. And divide by 4. Y equals 26. Remember, I'm not solving for y here. I'm solving for the measure of angle BCD. So we have to actually do that. Whoops. The measure of angle BCD equals 3 times 26 minus 16, which is going to give me 62 degrees. So my final answer, 62 degrees. Now we want to solve for the measure of angle C. Let's see what we've got here. A and J are clearly congruent. I already know that D and Q are congruent because the tick marks are already here. So two angles of the two triangles are congruent. What does that mean? That means that the third angles have to be congruent. H and C have to be congruent. Angle H is congruent to angle C, which means if the measure of angle H is 61 degrees, then the measure of angle C is also 61 degrees. That is the third angles theorem. If you learned something, please like and subscribe, and stay tuned for more videos.